Hey guys, how you doing? Mike Sinclair here. Okay, so I'm kind of tight. Ooh, stretch out. Ugh. Okay. Anyway, subject matter today. We're going to talk about something that you're going to be like, Mike, you know about that stuff? A little bit. It's called quantum physics. Okay, I know I look like a quantum physics guy, but I know a lot about it from the layman's standpoint. I'm not a scientist. I did take engineering when I was in school, but a lot of people hear about quantum physics and quantum computing and quantum stuff, and they don't know what it really is, right? So I'm going to try to explain a little bit, like an easy explanation of it, why you need to know about it, what's coming up, how it could affect your business, how it could affect your life, how it's going to affect computing, how it's going to affect a lot of things, right? Because a lot of things are going to change when it becomes more mainstream knowledge. We're actually at the beginning stages of it, okay? So I'll dive in. So bottom line is, I guess I can explain it to start like this. So we have like our physical universe, right? What we see, what we're involved in. Some people believe it's a matrix and it's a hologram, and to certain degrees, I'm sure there is a lot of hologram stuff going on. It's just how it is. I believe that's another subject matter. But here's the thing. So to break it down, basically, laws of physics are in different types of, let's say, physical bodies or physical. And I'm winging this a little bit. This is non-rehearsed because I know enough about it. I believe surfacey stuff. But let's call it a physical ecosystem, if you want to call it that. Okay. So we live in the world, universe. This is our environment, and so it has a certain amount of physics that we are utilizing and we use every day in order to maintain ourselves, right? There's laws of gravity, there's speed of light, there's sun, moon, gravity, time, space, all these things that we need around us so that we can interact with different objects, different things, so we are in tune, right? Whoever the creator is said, I had to make you guys have something that you could work within, some framework, right? There's a table here, there's light, there's a certain amount of colors, band that we can see as humans, a certain amount of sounds we can hear, certain levels of consciousness that we're born with that we can communicate with other humans and other things, and we don't get overdosed. And that's another subject. There's a lot more levels of consciousness and a lot more things that are conscious that are on the planet with us that we believe are not conscious because we just don't have, we never got that memo of that station, of what that station is. You know, I mean, to the point where, and again, this is another subject matter, but like trees and animals and plants and even inorganic matter, like a rock, okay? Everything is communicating. Trust me, it is. We couldn't get overdosed. So if you walked out to your house and everything in the entire world, you were able to be at all those radio stations, or you want to call them communication consciousness levels, your brain would explode. So the creator said, I'm going to close that bandwidth down to here so you can still function as a human being. Same with your light, how much things you can see with your naked eye. You had to narrow that down so you wouldn't get overdosed, just like going to a buffet, right? There's 100 things on it out. You ain't eating them all, right? If you can eat them all, your stomach would explode. Same with your brain. So let's talk about levels of consciousness, right? Let's talk about how it works. I'll dive in. So let's say the universe is our world. That's how it works. It's all the physics that are here. Your phone has its own, let's call it laws of physics. So I'll give you an example of that. Let's go with your computer first. Let's say your computer has its laws of physics. Your phone has laws of physics, right? The world has laws of physics, and I'll explain how that works. Let's say if you're on your laptop, right, and I go, hey Mike, hey Jimmy, I want you to go to New York, go visit your mom, right? Laws of physics of the earth, you'd have to hop on a plane, take a 6-hour flight, go to New York from California, go see your mom or your family, right? That's the physics of that. It's gonna take you 6 hours. Even if you could travel the speed of light, it's still gonna take you a while because you still gotta get to the airport. It's gonna take you time to get on the plane, right? You're gonna spend 45 minutes at the airport, 45 minutes to get out the airport, and half a second in the air because you're going the speed of light. So it's still gonna take you 2 hours into New York anyway. But the point is, that's the physics. Now, fixing your computer, I say, go on, talk to your mom. You hit a button, go on WhatsApp, Skype, Zoom. You're in New York, just like that, right? That's the physics of your computer and the internet and satellites. You got to see your mom in 1 second instead of 6 hours. So your computer is a physical ecosystem that's happening, and that changed the physics of that. Your phone, same thing. I could say, hey, I want you to, play a movie, something on Netflix, right? The physics of your phone is you can press a button and be watching a movie in what, 2-3 seconds. In the old days, how were those physics? You'd have to get in your car, drive down to a movie theater, go down to a place to rent a CD, buy a CD from your local store, come back, pop it in your VCR. So the physics of your phone allows you to watch a movie, right? So quantum physics is almost the same thing. You got to tell yourself, if I showed this computer to a early man, let's go back, like super early man, first men on a planet, and I showed him a computer, he's gonna try to grab my screen. Say, there's somebody in there. What's up? He's gonna turn and flip around the back. Yo, man, somebody's up in that computer. How'd you shrink that dude, right? How'd you get that guy to fit in your computer? And I'm a three-dimensional object at that. So if I was just a flat thing, he'd be like, yeah, okay, that makes sense. Screen's flat, person's flat. No, screen's flat, I'm 3D, right? I'm a hologram in a sense because I'm three-dimensional on a flat 1D screen or 2D screen. So the point is, that person, that caveman, would be in shock that I was able to defy the laws of physics by speaking to someone in another country, having a conversation, watching a movie, and he'd be, if I said I'm gonna pull up, a steak dinner, he'd be trying to eat the computer, right? How'd you make magic on the screen with a steak dinner there? I'm hungry. You just made food in an instant. Okay, so quantum physics is the same thing. You have to take yourself out of what you understand physics to be and put yourself in the quantum world. Quantum world says there's something called reverse symmetry. Reverse symmetry means things can go forwards in time, things can go backwards in time, right? There's you could take a ball, if you had a football and you threw it forward, it'll go backward, right? You could say that they have something called superposition. So it means that all possibilities are everywhere at the same time. So let's say, for example, if I'm looking for my dog and I open up my front door, there's a million dogs, all my dog, but there's a million of them. Everywhere I can look, my dog is there in every single spot. It's called superposition. Everything is everywhere. It's called superposition because there's multiple possibilities. Everything's a possibility at the quantum level, okay? So why is this important to know? It's because we're starting to dive into and starting to understand it, and it sounds super wacky, right? But you got to use, wackiness is only wackiness when you attach it to a time. Wackiness is not wackiness when the brain catches up with the knowledge of how we do it. Like I said, if I showed a computer to a caveman, it sounds like wacky, it sounds spooky, it sounds creepy because he cannot fathom a computer screen with a person talking to him in 3D and how I can magically make things appear on my screen, right? So to him, it's wacky and crazy. But to the guy who's modern day, it's just a computer, it's an Apple, it's an iPhone, right? So it's your brain did not catch up with the physics, so it's wacky. With the level of quantum now, we're like the caveman. How can you go reverse in time? How can you throw a football forward and go backwards? How could you have a dog in every single position when you open up your front door looking for your dog? That's wacky, right? No, but it's not. That's called quantum physics. It's and we don't understand it. Now, on top of that, you can have the observer, meaning me, looking at something can change the physics behind it. So let's say, for example, I'm looking for my dog and I open up my door and there's a million dogs. As soon as I focus in on one dog, that's where the dog is. All the 999,000 dogs disappeared and the one dog was sitting there because me observing where that dog is, or it appeared. Okay, so it basically means that everything is possible until you collapse it into its point. Like you collapse that possibility into the fact. Okay, sounds creepy, but this is how it works. So I explain to people this way: if that wasn't possible, and quantum, which is like it's like the level that controls everything we see, if that wasn't there, then we couldn't have what we have. So it's like you look at a computer, you go, well, this computer, okay. Well, if there wasn't I don't know how many, I'm not a computer genius or anything, but there's millions of processes happening every couple seconds, right? In order for me to even do this video. So there's a million things happening in order to control this video. So I'm giving you a video, right? Quantum is there's a million wacky things happening in order for the world to do what it does. To have a desk, to have a table, to have gravity, to have light, sun. There's a million things happening every second in order for that to maintain. Now for us, a computer, it works pretty logical. Things go forward in time, right? It's forward in time. This is considered low tech, compared to quantum, this is super low tech. Quantum is like way above what we could imagine. Just like a caveman, what was his means of transportation? Feet. Then it went from feet to tires, from tires to probably a bicycle, from a bicycle to, you know, I don't know, horses. Well, horses were always there, right? The cars to trains to planes to spaceships, right? Planes to rockets, whatever. So there's that evolution. So we went from, you know, paper to typewriter to computer to iPhone, right? That's our trajectory. So what I'm saying to you is, we're going into the quantum world now, where we're those brand new babies looking at something that we don't understand. At the end of the day, it's a super duper powerful thing that's going to happen. Quantum computing is coming out where it can make calculations on things that would take a regular computer thousands of years. It can do in seconds. A computer works as, it looks at a library, and you said you're trying to find the word called cat, C-A-T, like a cat, and there's a whole bunch of books in this library, and you said, I want to find the word cat. A regular computer goes through every single book, every single line, to find that word cat. You hook up more computers, you have a whole bunch of computers going through trying to find that word cat. If you put 1,000 computers check in, but they're all still going through every single book. You can have some start on the left, some start on the right, and one start at the top, library at the bottom, and they're all searching until they find the word cat, and then one says, I found it, right? Where quantum goes, how many books are in the library? 1 million. Bam, check them all. Just one pop, it just pops. Bam, here's cat, like that. It doesn't have to go line by line by line by line. It doesn't do it. It doesn't operate. It operates totally differently. So when we're getting into that space, that means that a lot of things are going to change. So when computers get that fast, I mean, you're talking about reiterations of software, solving problems with medical, solving problems with transportation, solving problems with, human genome, things organically recreating things, making new molecules and new substances that aren't available. There's certain things that we can't make that we know that if we made them, we'd have advances. But we can't make them because we don't have the computing power to be able to make certain things and do the calculations. I'll give you one quick example of that. There's an element called, and this is still in question, but they did put it on a periodic table. It's called element 115. And basically they're saying that it has anti-gravity capabilities in this element 115. They just added to the periodic table recently. But we can only make it last for a certain amount of like milliseconds, and then it kind of, we can't control the state of it, so it goes away. But with quantum computing, you get some guys in the room, maybe after 3-4 years, they're figuring out how to control that element so it doesn't dissipate or it doesn't go away, and they can hold it in its state. You could put that in a plane, ship, car, and float off. It's anti-gravity. Again, don't quote me exactly. Most scientists are saying that it has a capability of being that. But that's what it can do. But we can't do that because with the current computer power we have now, and we don't have enough brain power on it, but eventually we'll probably be able to figure that out. So getting back to quantum, it's a huge thing. A lot of people don't just hear the word, they don't know what it really is. But essentially, I believe that you have to have things do wacky things in order to make the things outside be stable, okay? And if the universe wasn't like that and it behaved like we behave, we wouldn't be here. If it was linear, if it couldn't go back in time, if it couldn't go sideways, up, down, and it had to have no laws to control laws. In other words, when you're watching a movie, you don't see it until the movie's cut, reversed, chopped up, edited, people's face cleaned up, stuntmen, what they call those things, the wires that are connected to the guy so he can fly like he's playing Superman. All that stuff is happening. Rewind, cut, rewind, do over in order to present a movie to you that you'll like, right? Quantum is that. It's saying, hey, if we couldn't go reverse it, if we couldn't go backwards and fix something that we screwed up, the universe, if we couldn't stop time and edit, if we couldn't have possibilities everywhere at the same time, if we couldn't create, like gaps and spaces and time gaps and all this stuff, and using and your consciousness can actually determines what happens, what's presented. Like if you see 1 million dogs and you focus on one, all the other ones disappear. If we didn't do all those wacky things when you're watching the movie of life, it wouldn't look right. It'll be jacked up. It's like if you watch a movie and say this movie's uncut, unedited, the stuntmen are really jumping off of buildings with no wires. If they miss the mark, they're dead. If the bullets in the gun are real, if we make a mistake, we're just gonna roll. And you went and go watch that movie, you'd be like, damn, this movie's jacked up. Everything was jacked. There was no editing. So you have to look at quantum, make it in a simple term. Quantum physics allows the universe to have no constraints to make it right. And if you think about it, it makes sense, right? If the universe worked on the same principles as we did, how could we live out from behind? If the universe wasn't behind the curtain pulling tricks, how could we be performing on the front of the stage without any mistake, right? What do you do when you watch a play? They darken the room and they close this curtain, and then people go in there and change up all the stuff and move all the stuff around, create the new stage and everything, right? And then they open the curtain, you're like, oh wow, how'd they do that? Because they want to give you the right example, so they don't want you to see all the crap that goes on behind the stage, for them to paint a picture of you so you'll enjoy the show. So quantum physics allows the universe to close the stage, to close the curtain, and do all this wacky shit. So when you wake up in the morning, you're like, the world is beautiful. Because it can go reverse in time, everything is everywhere, things go forward and backwards, multiple possibilities. There's so many different things that are wacky. Oh, there's a thing called entanglement. Entanglement means if there's one, I'm forgetting the word of we'll call it, I forgot the term of the type of molecules, but say there's one here. Keep it simple for now. Let's say there's a marble here and a marble here. And you entangle those things, the chemical entanglement to these two things are an entanglement. And you send one off millions of miles away. I mean, light years away. If you create a reaction in this one automatically repeats the same exact reaction simultaneously with no delay. So what does that tell you? It tells that it says that they're entangled. Both of these objects are still one, even though they're two separate items or two separate things. They're still connected. So that makes sense in a way too. Look at your computer screen. If you showed it to a caveman and said, "Hey, I'm gonna take my mouse and I'm gonna move this item over here in the corner," it's going to drag something over in the other corner. And he'll go, wow, how'd you do that? In his world, if there's a rock here and a rock here, you move this rock, that rock ain't moving, right? If you move this rock, the caveman go, you move that rock don't move. You cut that tree don't get cut. On a computer screen, you could do something over here and it could be making something go over here, right? Because the program it's entangled in the hardware, right? It's entangled in the hardware. I could grab my mouse right now and drag something across the screen. It's entangled. It's attached. Where's it attached? Is it really attached? No. The hardware is saying that window you're moving from left to right is like, I don't know how many pixels it is. It might be 10,000 pixels, but each pixel is making the screen like it never blinked. I moved that whole entire window, right? All those pixels are coming with it. Isn't that entanglement? I just moved all those pixels. They're all one pixel is one pixel, one pixel. I moved them all at once, seamlessly. So the caveman goes, how'd you do? You got magic. You moved that whole screen at once. No, it's entangled. Same thing as you have an item over here, an item over here. It looks far away, right? But when you move one, you change the other. It's entangled. So anyway, that's it. That's my little science lesson for today. I think I said enough about quantum. It just, and you can look it up. You can, and I'm telling you stuff that I've studied. I know about it, and it's pretty intense. I like studying stuff like that because I know that it has an effect. Later on in life, computers are going to be quantum. People are going to be doing things a lot faster. There's going to be a lot of technology that's going to come out. I'm into technology also. So understand that, learning stuff about this is good because you can have your plan A, B, C in the future. When things start to change, you're not just finding out about it on the fly. You have some forewarning of what's coming. And it'll be here pretty soon. They already got computers now. They're getting into a size of a chip that's about the size of half a playing card. The quantum chip, when before was the size of like 5 refrigerators, but they had the actual quantum computer wasn't that big. It was probably about the size of a refrigerator, but they had to cool it at a certain level, like super duper colder than space, in order to freeze some certain molecules so that they could do these reactions in order for it to provide the computing power that it needed. It took a lot of energy. There was only like 2 computers. I think it was Google had D-Wave, and was it Google? I think it was D-Wave. Google had D-Wave, and then IBM had another one called something. I forgot. There's two of them that was got. Oops, my computer. Two of them that were made, but now a lot of people are coming out with them. So anyway, that's a lesson on quantum. Stuff is true, man. It's crazy. There's a lot of stuff there that's wacky, but understand, in order for you to have the life you have and the things and enjoy the things you enjoy and do, somebody got to be behind the curtain doing some stuff that you can't even fathom, and that's quantum. It has to be doing crazy stuff in order to give you a civilized world. It has to be uncivilized, right? Okay, take care.